Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with the drivers A to Z DSA course. Just in case you're for the first time here, there's a link in the description. Please do make sure that you check it out because it is highly beneficial for you. So till now I have covered up till this particular problem. And in this video I'll be covering up the last problem of the arrays playlist. So just a quick update. I've made a drivers DSA playlist separately. And over here we will be adding all the CDs. And if you go over there, it's classified into much compact sections, and you get the articles, you get the practice link, you get the video solutions, everything. And if you go over here, we will also be updating the format of the articles very soon. Like in a couple of weeks, we'll be updating the entire format of the article. You'll be able to read the articles in a much better way. So in the article, you will be getting all the approaches. C++, Java and Python code will be added. So everything is present in the article. So please do consider checking out this, because going forward, you will find all the playlist, all the DSA playlist under this section, and you can practice them easily at a place. So I think that's a lot of promotion. Now let's quickly get back and get started with the video. So what does the problem state? The problem states that you will be given an array, and the array will be containing integers. And your task is to find me out the maximum product sub-array. Now what is the definition of a sub-array? The definition of a subarray is any contiguous part of the array. Any contiguous. For an example, this is a subarray. For example, this is a subarray. For example, this single element is also a subarray. Also, the entire array can also be called as a subarray. Something that you cannot say as a subarray is, maybe if you pick up 2 and minus 2, this is not a subarray. This is a subsequence. So your task is to tell me which subarray gives me the maximum product. So if you take this particular example, so in this particular example, if I pick up 2 and 3, the product will be 6, and this is the maximum product that you can get of all the subarrays. So if this problem comes up in an interview, what is the first solution that you should be telling to the interviewer? That is definitely the brute force. Whenever the problem has subarray, what is the brute force? The brute force is generate all the subarrays, and I've already done that in so many problems. How do you generate all the subarrays? You know the first subarray is this, the second is this, the third is this, the fourth is this. And then it's 3, 3, 2, and then this. Then it's this, and then this. So basically, we stand at a point and we expand, and we expand, and we expand. So what I can do is, I can say, okay, for I equal to 0, I lesser than n, I plus plus. So what will happen is, I will be first standing here, then I will be standing here, then I will be standing here, then I will be standing here. So whenever I stands here, what's the first subarray? It's just 2. So maybe J can start with whenever I is. So let's quickly start off J right from I and go ahead till N. Perfect. So if I is here, J is here, what is the subarray? It's from I to J is the subarray. The next moment I will be here, J will go here. So it's from I to J. The next moment I will be here, J will be here. So it will be from here to here. The next moment I will be here, J will be here. So it's from here to here. After that I will increase and I will be here. So this is the next subarray. Next subarray will be this. And then the next subarray will be this. So the subarray is from I to J. We know that for sure. So maybe we can run another loop which goes from I to J. So there will be 3 loops. So if you run 3 loops, it will always give you all the subarrays. This is the standard procedure. What am I looking for? Product in a subarray. How do I get the product? Let's see. I'm going from I to J. That is the subarray. Maybe I can keep a product as 1, and every time I'm going, I can do product equal to product into array of K. Perfect. Array of K. And this will give me the entire product from I to J, that is the subarray. Once I've got the product, I need the maximum. Maybe I can store maximum as int mean. And over here, I can say maximum equal to max of maximum, whatever current product this subarray is generating. This will be my extreme naive force, which is generating all the subarrays. If I ask you the time complexity, can I say it's like n? It's near about n. It is again near about n. So there are 3 loops which are running, like 3 nested loops. So thereby, the time complexity is not exactly n cube, but it is near about n cube. What about the space complexity? It is somewhere big O of 1. Obviously, the interviewer will not be happy with the n cube and he'll ask you to optimize it. So the moment someone is asking you to optimize n cube, you move towards n square, right? You try to think of something related to n square. Can I think of n square? I can. If you have seen my previous videos, I think you can think. Why? Let's analyze. For the first time, the subarray was just 2. For the next time, j moved and the subarray is 2, 3. For the next time, j moved and the subarray is 2, 3 minus 2. For the next time, j moved, the subarray is 2, 3 minus 2, 4. What's happening? Over here, the product will be 2. Over here, the product will be 6, which is basically a multiplication of 3. Over here, the product will be 6 into minus 2, that's minus 12. And over here, the product will be minus 12 into 4, which is minus 48. So basically, every time you multiply a new number. So do you actually need to run through the entire subarray? You don't need to. If you can just store a product variable as 1, and every time you get the new value, because only the new value is added as j is moving, only the new value is added in the new subarray. So the new product can easily be found out, and you can say maximum equal to max of maximum comma product. So this can be trimmed out. So if I trim it down, can I say the complexity has been trimmed down to n square, right? Now over here, again, you're doing n square. So the interviewer will not be happy and he'll ask you to optimize n square as well. Now, if I'm asking you to optimize n square, where do we move? We move towards big O of it. So let's try to think of a solution which is near about big O of n. So this problem has 2 optimal approaches. One of them is purely observation based, and this is the one you should tell in the interview. Why? Because this is the most intuitive solution to this particular problem, and you'll be easily able to explain your thought process. And the other one will be using the modification of Cardan's algorithm. Again, this method you should never tell in the interview. Never ever, because this is not that intuitive. It is not that intuitive. You can go over a lot of YouTube videos. People will just write the formulas, do a dry run, and they'll say, yeah, it's working. But this one is not intuitive. So I will not be teaching this, because I also feel like it's a lot of like cramming algorithm. Instead of going for this, go for the observation based, because it is the same time complexity and the intuition is much visible. So please in the interview, do not go for this. Rather go for this. If you want to read about the Cardan's, you can definitely read about it, or you can watch the other YouTube videos. And once you've seen them, you'll understand why was Stryver saying that it's not intuitive. So let's quickly go and understand the observation-based approach. So let's talk about the observations that I was talking about in the first optimal approach. The first optimal approach has a lot of observations. The first one, if I ask you a very simple question, what if the array has all positive elements? You'll be like, if it has all positive elements, the answer will be multiplication of everyone. I'll just pick up everyone. Imagine this array was something like this. Then you'll just take up all the numbers. That will be your subarray and you'll multiply everyone. Very easy. What if it has even negatives, and rest all are positive? So something like 2, 3, minus 2, 6, minus 2. In this case, you have 2 negatives, which is like even number of negatives. Again, you will be like, multiply everyone. Because if there are even number of negatives, and I multiply everyone, I think I will get my answer. Okay, perfect. 3, what if there are odd negatives? What if there are odd negatives and others are positive? In that case, you will be like, okay, if there are odd negatives, let me probably take some examples. Something like 3, 2, minus 1, 4, minus 6, 3, minus 2, let's say 6. So I've taken something like this. So I have odd negatives. 1, 2, 3. There are 3 negatives. 3 is a odd number. So if I have 3 negatives, what should be my ideal scenario? Because I know one thing. If I take everyone, what will happen is I'll end up multiplying 3 negatives. And 3 negatives on multiplication will give me a negative, which I don't want. I want a maximum product. Maximum. I want to increase it. So how do I increase it? If I just go towards positive, so my idea will be, what if? Probably I can ignore minus 1. What if I can ignore minus 1? I'll be like, I can. In that case, I'll have this much. I'll have this much. Okay. Either of this, which is 6, and this will also be a positive. Because if I ignore 1 minus, everyone else will be positive. Because if you try to multiply, there are even... What if I ignore minus 6? In that case, this might not be. So this will not be a good case. What if I ignore minus 2? In that case, I'll have 6. And I'll have again some numbers which gives me positive. So can I say, whatever answer you are getting, if you have an observation, let's observe. When you ignored minus 6, this was your answer. Like, this is the maximum. When you ignored minus 6, whatever array you were taking was here and was here. Whenever you ignored minus 2, it was here and it was here. So something to observe. Whatever you are taking, it is either prefix or it's either suffix. I think I'm correct. Let's have an observation again. It's either, like if you avoid this, it's either prefix or it's either suffix. If you avoid this, it's either prefix or it's either suffix. If you avoid this, it's either prefix or either it's suffix. Correct? Now you might ask, but Striver, when we remove this, there is one negative. Okay, now this case will never give you an answer. Because a better case will always be removing this and there are 2 negatives. So there will always be a better case. So, okay, we will always get even negatives. So we kind of figured out that our answer will be either in the prefix multiplication or will be either in the suffix multiplication. Valid? How does this work? Even if I take something like minus 2, 4, 5, 6, minus 7. So there are 2 negatives. So the entire prefix is the answer. Or you can say the entire suffix is the answer. Right? Even if I have something like a minus 1 here. In this case, if you remove this, the prefix is the answer. If you remove this, the suffix is the answer. If you remove this, the prefix or the suffix is the answer. So I kind of got an idea that I need to start from the first, get all the prefix max. I got to start from the back and get all the suffix max. And at whatever junction, whatever is maximum, that will be my answer. But am I done? I don't think, because we are missing still one case. What if it has zeros? Imagine I give you something like minus 2, 3, 4, minus 1, and again a 0. And then minus 2, 3, 1, 4, and then again a 0, then 4, 6, minus 1, 4. Can I say this? I know 3 conditions. And if I have zeros, I know one thing. If I take this, no matter how big the numbers are, if there is a 0, the multiplication will be 0. If there is a 0, the multiplication will turn out to be 0. So taking a 0 doesn't make sense. So can I say this is a separate array, this is a separate array, this is a separate array? Logically makes sense, because there's no point in considering 0. And can I say I can find the max over here, I can find the max over here, and I can find the max over here. And whatever answer I'll get, that will be my answer. Quite simple. I'll take a max of this, max of this, max of this. And whatever answer I'll get, that will be my answer. So basically 3 different arrays, 3 different paths solved. Because the subarray will never have 0. Will never be an inclusion of separate ones. Okay, I've also solved this. So we have somehow got the observation, right? Now it's time to implement it. I might be thinking how to handle this 0. I'll tell you that. But I'll just take this particular example, which is 2, 3, minus 2 and 4, and try to implement it. What did we know? Either the answer will be somewhere of the prefix or somewhere on the suffix. So let's keep a max as a very minimal number, which is int mean. Let's keep a prefix equal to 1. Let's go to 2. So prefix will be multiplied. So it's 2. It is 2, which is better than maximum. So you'll update 2. Next it will go to 3. So it will be multiplied with 3. So it will be 6. So the max will be updated to 6. Next it will go to minus 2. So this will be minus 12. So max will no more be updated because it's minus 12. Next we will go to 4. So this will be minus 48. It's no more updated. So apparently you saw this prefix was the max, and that is what is stored. In the next step, let's start from the back. Let's keep a suffix as 1. So you have 4. Multiply 4, you'll get 4. Next you get minus 2. This 4 is not greater than 6, so you'll not take it. Next is minus 2. Multiply, you'll get minus 8. Next is 3. Multiply, you will get minus 24. Next is 2. Multiply, you'll get minus 48. And 6 value was the maximum. Thereby, this is your answer. Which is this prefix max. Which is this prefix. So what you did was you tried out all prefix and you tried out all suffix. And you took the maximum of all of them. And it's pretty simple. But now you might be thinking, but Striver, how do we implement it with zeros? It's easy. Prefix is 1. Multiply minus 2. Multiply minus 6. Multiply minus 24. Multiply plus 24. So this till now is plus 24, right? The moment you move to 0, what does 0 give you? The prefix will be 0, 0. So if you carry 0, 0 will be carried. So what you'll do is, whenever you see 0, you'll turn it back to 1. Whenever you see the prefix multiplication has got 0, you'll turn it back to 1. Because that means you're starting off new. Because of the multiplication of 0, it was 0. You're starting off new. So again the prefix will be computed like minus 2, then 3, which is minus 6, then it will go to 1. So in this way it will be computed. So this is how you will do it. Whenever you see 0, turn it to 1. So if I have to write the code, it will be like, once you go from the front, once you go from the back. Do you need to do that? I can actually do it in one go. Yeah, it's simple. It's actually very simple. If you know basic array, you can do it. What I'll do is, I'll be like, okay, let's do it in one go. So I'll keep the prefix as 1. I'll keep the suffix as 1. And I'll iterate from I equal to 0 till n minus 1. And what I'll do is, I know one thing. If at any moment prefix turns 0, that means we are at a new start. So we just make it. Or at any moment suffix turns 0, that means we will restart. Quite simple. We'll do this. And what can I say? Prefix is equal to prefix into array of I. What that will mean is, first time it will do this, next time it will do this, next time it will do with this, next time it will do with this, right? What about suffix? Suffix should be from the back. So suffix into array of n minus I minus 1. So whenever I is 0, this will be n minus 0 minus 1, which is n minus 1. Whenever I is 1, it will be n minus 2. Whenever I is 2, it will be n minus 3. So it will automatically come from back. And your maximum can be said as max of maxi, comma max of either the prefix will be your answer or from the suffix will be your answer. Quite simple. And this will be it. And you can return your maximum. In case my handwriting was not good, you can look at the cleaner code over here. I've written the cleaner code and it is accepted as well. What is the time complexity? I'm just doing a big O of n traversal and couple of operations. So can I say the time complexity is nothing but big O of n? Yes, which is much better than what we did in the previous one. What about the space complexity? It's a big O of 1. If you're still thinking, why is this working? Now, you need to think yourself. Now, I did a couple of examples. I cannot do a lot of examples because the video will go long. So what you need to do is take a notepad, write down multiple examples and try to solve each of them. And with every example, it will get more clear to you why is this method working, and you'll understand yourself. You don't need anyone to explain you. It will get to you by yourself only if you do these examples on using pen and paper. So please do it, okay? So going back to the sheet, I can mark this one as done as well. With this, we wrap up arrays. Finally we did. So in case you have understood everything about this lecture, please do consider giving us that like. And if you're new to our channel, what are you waiting for? Kill that subscribe button, because that is the only thing that motivates me to make these kind of videos. If you haven't followed me on Instagram, Twitter and LinkedIn, all the links will be in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.